There was something wrong with the Teachment app today. So we wait for a few more minutes. Be connected, remain connected. We are allowing the students to join now. We are allowing them to join. Almost 40 of you have joined so far. We wait for a few more minutes because today's class is very crucial, very important topic we have on nitric acid. In the meantime, one by one you can clarify your doubts with respect to that ammonia chapter that we had discussed. We begin with Rishabh Kumar. Rishabh, can you hear me? Rishabh? Just I can't hear your voice, Rishabh. Your speaker was on for a moment, then.
Yes, sir.
Yeah. Do you have any doubts to clarify regarding that ammonia topic that we had discussed in the previous class?
No, sir.
All right. Alok. Your speaker is on. And Akshit Srivastav. Good morning, Akshit.
Good morning, sir.
Can you hear me, Akshit? Shagun, can you hear me?
Yes, sir.
Suraj Mandal.
Yes, sir.
Can you hear me?
Yes, sir.
Is the voice clear from this side now? From my side?
Yes, sir.
Yes, your voice is clear to me also. Rahul Gupta. Rahul
Yes,
Gupta,
sir.
I can find you. Yes.
Yes.
Am I audible?
Yes, sir.
And is the board clear to you all? The one that I have written?
Yes, sir.
Yes. So far, unfortunately, only 43 or 44, the number is being shown. I'm really surprised, but we don't miss today's class, because if we continue to miss, then the board examination will not wait for us. For 10-15 minutes, the Teachment app was not functional. I checked it with other sites also, other mobiles also, because other students were also attending the classes, of class 9, 11, 12, 10th, of course. Then with their cell phones also, the Teachment app was not working. Sometime it happens. So whomsoever are present today, your attendance will be marked. So don't worry. So out of 122, those who have enrolled, only 45 of you are being shown. Just 45 of you are being shown. Abin Soren, can you hear me, Abin?
Yes, sir.
Good morning to you, Abin.
Good morning, sir.
Mohar.
Yes, sir.
So just 45, huh? Well, we don't waste our time. I think that, or once again, I try to send message on WhatsApp. to inform them the class has already started, so that those who can join even if they are late. Just a minute, just a minute. Join the class now. Join the class now. Join the class on patient type chemistry now. So all of you, please get ready with your copy and pen, your writing material. Mohar, get ready with your copy and pen.
Yes, sir.
Apu Mandal, Mayank Modi, are you ready with your pen and copy, chemistry copy, Mayank?
Yes, sir.
Ayush Raj,
Yes, sir.
good. I can hear your voice very clearly. Am I audible now to you, Ayush? Ayush Raj?
Yes, sir.
Yes, yes. So you see now slowly they have started, joining the group. Now the strength 48, now it is being shown. So keep your copy ready, okay? Copy and pen, and whatever I ask you to write them in your copy, because you have your video also being recorded and saved. So today's class is on nitric acid, as you can see it from the board. In order to have a clear vision, clear picture of this board, you can zoom your screen also. So if you have that facility in your cell phone, you can get it zoom.
Sir,
Yes, Arpan, say.
sir, the camera is tilted, so you can fix that.
The camera is tilted with your phone, you can make it right.
No, I am using other devices.
Acha, Ayush Raj, is it okay? Is the camera okay?
Yes, sir.
It is okay, beta. Because here also with my camera, I am saying it okay. You can make correction with your cell phone, Arpan.
Okay, sir.
Ayush Raj, is it okay now? I hope. Is it still tilted?
Sir, it's okay. We can see it.
But is it being shown in a tilted way?
Sir, little bit tilted it is.
Slight, because that camera position and all, slight, few degrees only.
Yes, sir. Sir, yes,
No.
sir. Slide in a slide manner.
Slight, ekdam slight, you see.
But it's okay, sir. We can
It is
understand
okay.
it.
Yeah, you can, and then if needed, you can zoom that screen also, okay? Zoom it. So then we begin with the class, beta. We begin with the class. Today's chapter is on nitric acid. And we have just 3 topics to be discussed as per syllabus. We begin with the first topic, which is about the lab preparation. Lab preparation from KNO3 or NaNO3, potassium nitrate or sodium nitrate. So what is our first topic today as per syllabus? The lab preparation of nitric acid from potassium nitrate or sodium nitrate. Okay. So from these two only questions will come in your exam. All right. So remember the 2 reactants. They are either potassium nitrate or sodium nitrate. Now, we straight away enter into that equation. We begin with that equation part. We can mention it as A. The first one is about the equation. Now, if I write that equation with potassium nitrate, KNO3, when reacted with sulfuric acid, H2SO4, the concentrated one, at a temperature of less than 200 degrees Celsius to form potassium hydrogen sulfate and HNO3 vapors. Write this equation. At first you write topic A. The first topic A. Start writing. Topic A is related to the lab preparation of nitric acid from potassium nitrate or sodium nitrate. Continue writing. Then you write that equation also in your copy. Vishal Kumar, are you writing it?
Sir.
Yes, do write, okay, because you know that examination will be there. I'm talking of your ICSE board exam. It will be conducted because in CBSE also the same instruction was there given to the 12th students. Class 12 students have also been informed to get ready with their examination. And they have mentioned the syllabus, the question pattern, everything. I'm talking of 12th. So definitely when for class 12 it will be conducted, class 10 will also follow it. So keep the notes ready because on this Teach Me tab, I'm teaching you strictly based on syllabus. Now, once you write that equation, then we can raise a few questions from it. Like the first one is about the reactants. The first one is about the reactants. Okay. Now, Ayush, I begin with Ayush today. Ayush, can you name the two reactants? Which two are the reactants for the lab preparation of nitric acid?
Sir, potassium nitrate and conc sulfuric acid.
Very good. From this equation only, you will find, you will get a number of those informations, answers to all the questions that I ask it to you. So the two reactants are, one is potassium nitrate and the other one is concentrated sulfuric acid. Now, instead of potassium nitrate, you can also take sodium nitrate. Do remember their common names also. You can find them from your book. The common name of potassium nitrate, niter, and sodium nitrate, chili saltpeter. So these two you can take it from your book, the common names of potassium nitrate and sodium nitrate. Now, here I ask you one question to Opu Mandal. Why is this
Yes, sir.
conc sulfuric acid preferred to I'm writing it, preferred to HCl acid? Come on. Why is conc sulfuric acid preferred to, here I put that question mark, and you also write it in the same way. Do write the questions also that I raise in your copy. Take a smart note on your copy. So Opu Mandal, can you say as why concentrated sulfuric acid is preferred to hydrochloric acid, concentrated hydrochloric acid? Ayush Raj?
Yes, sir.
Say, give the answer. The same question was raised in that HCl topic, lab preparation of HCl. There, sulfuric acid was preferred to nitric acid. Here it is just opposite. What is the role of concentrated sulfuric acid in this reaction? Come on. What sort of role is being played? Ayush? Any idea? Bit unfortunate. You'll have to remember all these. Study of compounds, HCl chapter only we had discussed. Here, conc sulfuric acid acts as a non-volatile acid. Now, can you remember it? Recall it, Ayush.
Yes, sir.
Yes, do remember, these are the probable questions because not much are there to be studied. Remember that for the exam, this limited and revised portion that has been given. So what is the role of concentrated sulfuric acid in that reaction? It acts as a non-volatile acid. Okay. And it is preferred to HCl because of the same reason as HCl acid is a volatile acid. Volatile means it escapes in the form of vapors, and along with HNO3 vapors, you can also obtain HCl vapors. A mixture of these two could be obtained. Whereas corn sulfuric acid has a higher boiling point and hence it does not evaporate easily. Here in that equation you will find HNO3 is being collected as vapors. Now take down that question, question number 1 for the reactants category. Why is conc sulfuric acid preferred to HCl acid? All of you write down this question. All of you, all 45 of you, those who are attending the class. Very, very unfortunate. Such a less number of students today. For one of the most crucial topics for the subject. Why is concentrated sulfuric acid preferred to hydrochloric acid? I have already stated the answer. You can get it from the recording. You can also get it from your book. So these two are the reactants and we can raise two questions from this reactant category. One is to name these potassium nitrate and sodium nitrate with their common names and the reason as why conc sulfuric acid is preferred. Now the third one is about the products. The main product is nitric acid. So here this nitric acid is obtained as vapors. The nitric acid, one of the major products, is obtained as vapors. All right. So the main product will be HNO3 vapors. The fourth one is the condition. This is again an important one, the condition part. Here for the condition, the main condition is that you'll have to take the temperature less than 200 degrees Celsius. This is the main condition for the reaction. Remember that. Main condition for the reaction. Here from that equation you can find it out. Look at the board. At a temperature of less than 200 degrees Celsius, potassium hydrogen sulfate is formed. KHSO4 is formed, which being soluble could be easily removed from the container. If a temperature of more than 200 degrees Celsius, if a temperature of more than 200 degrees Celsius is taken, remember I have put a cross, you see, and put a tick mark for that less than 200 degrees Celsius. With a temperature of more than 200 degrees Celsius, potassium sulfate will be formed, which will be difficult to remove from the container. Second, potassium sulfate, which is difficult to remove. Second, the possibility of the decomposition of the acid is there. Decomposition of HNO3 could be there at a temperature of more than 200 degrees Celsius. And the third one will be the possibility of cracking of the apparatus. So a temperature of less than 200 degrees Celsius is preferred because at a temperature of less than 200, potassium hydrogen sulfate is formed, which is easy to remove. At a temperature of less than 200 degrees Celsius, the decomposition of nitric acid could be prevented and the cracking of the apparatus could also be prevented. At a temperature of more than 200 degrees Celsius, all these three may happen. potassium sulfate will be formed, which is difficult to remove. Decomposition of nitric acid could be there, and the cracking of the apparatus could also be seen. Come on, write all these in your copy. So these classes are not at all the formalities, remember that. Wherever you go, the same thing will be taught, maybe with extra informations which may not be featured in the exam, but wherever you will be attending the class, this will be the core topic which cannot be ignored, which could never be ignored. So that was all about one of the conditions, all right, the three conditions that we had put. Now come to the next one. Next one, the fifth one is the setting of the apparatus. Setting of the apparatus. Now, look at the diagram that I had drawn it for you on the board. Look at this diagram, all of you. This apparatus, this one, where I am marking it with this green pen, this is called the retort, R-E-T-O-R-T, retort. In this retort, a mixture of potassium nitrate and Kong sulfuric acid is taken. You can see it, you can zoom it. You can zoom it on your screen and can notice it. This mixture is then being heated. And when this mixture is heated, you'll find vapors of nitric acid being formed, which will pass out from the mouth of this retort and will be entering into this round bottom flask. You see, this is the round bottom flask where nitric acid vapors are entering. This nitric acid vapors are then condensed by applying a shower of cold water. From the top you can find the tap. Shower of cold water is being applied over the container that cools the nitric acid vapors, and nitric acid vapors get condensed to form liquid nitric acid, liquid HNO3. And from here, this is the outlet for the water, the cold water that you had made to fall over that round bottom flask. This is all about the setting of the apparatus. So the setting of the apparatus is basically been done in two parts. This is the retort where a mixture of potassium nitrate and Kong sulfuric acid is heated at a temperature of less than 200 degrees Celsius. And this is the collector. This is the flask, which is also known as the collector, where the vapors are being collected and condensed into liquid HNO3 by applying a shower of cold water. So you can also, I mean, since the Teachment app is one of the better ones that I find, because you can also keep the recorded video of this one. After this, we discuss about the precaution. The precaution. Here you'll find that all glass apparatus, all glass apparatus, I mentioned it on the diagram over here, you see. All glass apparatus is required for the lab preparation of nitric acid, because nitric acid vapors are equally corrosive. Corrosive means they are highly reactive and attacks on rubber or cork. So if you close the mouth of these containers with rubber or cork, then these nitric acid vapors will react with the rubber and cork, will attack on rubber and cork, and hence all glass apparatus is used for the setting of the apparatus. Remember, all glass apparatus. And the second precaution is the temperature factor. The second one is the temperature factor should be kept below 200 degrees Celsius. After that, the collection of the gas. Collection of the gas. This is how the gas is being collected. You know, nitric acid is being collected. Nitric acid is formed in the form of vapors, which is collected by condensing the vapors by cooling them, where you can obtain liquid HNO3. This is how the collection is being made, by condensing the vapors. And finally, the seventh one is the identification. Identification. Identification means the detection of HNO3. Okay. So for this identification, kindly take the notes. Take the notes. Come on, at first you write all these. You take a screenshot of this one and write all these in your copy. Then I dictate you about the identification, with which we'll end up the first topic. Like this, there are only 3 topics, remember that. And it could be shortly covered up. In the first topic, we started with the equation, followed by the reactants, products, condition, setting of the apparatus, precaution, collection, and for the identification, I'm going to give you a few notes. Now, for the identification of HNO3, you write. It produces brown fumes, right? It produces brown fumes on heating. It produces brown fumes on heating. Then for that you'll have to support it with that equation, right? 4HNO3, I'm writing it also for you on the board, forms 4NO2 plus water plus oxygen. This is the brown fumes. Brown fumes. Write down that equation. So the first way to detect the gas is, on heating it produces brown fumes, and those brown fumes are of NO2, nitrogen dioxide. Second one you write for the identification. It forms reddish brown fumes. Once again you write, it forms reddish brown fumes when heated with copper metal. It forms reddish brown fumes when heated with copper metal. And the third one you write. It forms a brown solution. It forms a brown solution of FeSO4.NO. I have written it on the board. FeSO4.NO. It forms a brown solution of FeSO4.NO with FeSO4, with ferrous sulfate. This is all about the first topic. You study from this topic only and you'll find most of the questions being taken from here. Now the number from 45 have been reduced to 41 now. I don't know whether there is a network problem or they are intelligent enough to manage it by themselves. So take a screenshot once again of the first topic. Then we discuss about the remaining two. Remaining two topics are not that much difficult to follow. Rohit Murmu, shall I wipe out the board now? Rohit, sorry, Rahul. Rahul Murmu.
Yes, sir.
Okay. Don't leave the class, Rahul, Vishal, Ayush. Don't leave the class. Now, we discuss about the second topic.
Sir,
Yes, ask. Ayush.
sir,
Who is asking?
Sir. Agastya.
Yeah, Agastya, ask. Agastya Banu. Yes, yes.
Sir, why have you put a dot? What does it signify?
Yes, yes. Come on. Very good, Agastya. I just wipe it out for you and then I mention it in detail.
Okay, sir.
Then I mention in detail. Good. So clarify your doubts, okay? After all, again I repeat, wherever you'll be going, you'll be clarifying your doubts over there also. So why not when you get an opportunity here in the school? So there is a chemical test for the detection of the nitrate radical. Detection of nitrate radical. This is called the brown ring test. I'm teaching you slightly extra, Agastya. I hope that you will not mind to read extra, slight extra one.
Yes, sir.
Yes, I have mentioned it on the board, extra information. So brown ring test is meant for the detection of the nitrate radical, and this nitric acid also contains the nitrate part, no NO3 part. For this, you'll have to take that nitric acid, you'll have to add for this one. Remember, for the brown ring test, you'll have to add sulfuric acid conc. You can note it down.
Yes, sir.
You can note it down. Then FeSO4, or I can put it in sequence also. Nitric acid, then ferrous sulfate you can add, freshly prepared. And then you can add concentrated sulfuric acid. When you will add these three, at first nitric acid to that ferrous sulfate, then concentrated sulfuric acid, you'll find a compound FeSO4.NO being formed. This is called nitroso ferrous sulfate. Agastya Banu, this is extra one that I'm teaching it for you, because that simple question that you have asked, that cannot be simply discussed within a particular, by giving you few informations only. For that, I have to go extra. So there is a compound called nitroso ferrous sulfate being formed. This is the brown ring. This is the brown ring. Now come to your question. Here this dot signifies a weak bond, a weak linkage between FeSO4 and NO. So when this solution is being slightly disturbed in the experiment, in the practical, or it is being slightly heated, then this FeSO4 and NO gets separated. And once it gets separated, now remember, the brown ring was because of FeSO4.NO, and the brown ring is not between FeSO4 and NO that are separated from each other. Got it, Agastya?
Yes, sir.
So your question was, what does that dot signifies? The answer will be a weak bond, a weak linkage between ferrous sulfate and nitric oxide. You can take a screenshot of this one. A question of a very good standard. Let Let me say, Agastya Bhanu.
Yes.
So then, shall we move to the next topic?
Yes, sir.
Sir, one more
Yes,
question.
because we have to cover up the portion, cover up the syllabus also.
Sir, there
There
is
was
one
a
more
slight
question.
delay today that affects our patience. The second topic is about the industrial manufacture. Industrial manufacture of HNO3. This industrial manufacture is called Oswald's process. So what is Oswald's process? It is the industrial manufacture of nitric acid. And in this one, we will have to study about the equations and conditions only. So how simple is the syllabus? You see, if you want to read extra, then chemistry has unlimited source of informations. But within limit, very less we'll have to study. For the industrial manufacture, we'll have to study only about the equations and the conditions. This I teach you in the form of a flow chart. At the end, you can take the screenshot also. For this, 1 volume of dry ammonia is being taken. 1 volume. 1 volume. And it is mixed with dry air. Dry air, 10 volumes. Here you will find one question. I have put that integration mark. Please take a question for this one. Take down the questions first. Why there is a need to take a higher proportion of dry air. We discuss it shortly. These two are introduced to a catalytic chamber. Catalytic chamber. Let us mark it with 1. Let us mark it with 1. Now, what happens in that catalytic chamber? I'm mentioning the equations. I'm putting it over here. Ammonia reacts with oxygen in presence of platinum catalyst at a temperature of 800 degrees Celsius to form nitrogen monoxide and steam. So this is the equation. This is the reaction that takes place in the catalytic chamber. Okay. Now take a few questions. All of you take a few questions. Name the catalyst used. Name the catalyst used. Next question. Why is the catalyst initially heated? Why is the catalyst initially heated? Now listen, look all of you. From this equation, we can make it out that the reaction is exothermic. The reaction is exothermic. Exothermic means it gives out heat. And the reaction produces a lot of heat that maintains or sustains that reaction. You listen to my video again and again, you will be able to get the notes from there also. And the catalyst used is platinum. Then, as per this, you'll find that NO is being formed. The main product is NO. So NO, steam, and oxygen of air, then passes out to the heat exchanger. Heat exchanger. This heat exchanger lowers the temperature because it is highly exothermic. So these gaseous products are then introduced to a chamber which lowers down the temperature. From there, it goes to the oxidation chamber. From here, it goes to the oxidation chamber. Let this oxidation chamber be marked as 2. So I'm writing the equation for that oxidation chamber that takes place. This nitrogen monoxide that is formed in the first reaction reacts with oxygen at a relatively lower temperature of 50 degrees Celsius to form nitrogen dioxide. So nitrogen dioxide is the main product. Oxidation means gaining of oxygen, addition of oxygen. So to that nitrogen monoxide, oxygen is being added, which converts it to nitrogen dioxide. Finally, here you'll find the mixture of NO2 and O2 are then introduced to absorption tower. This is called absorption tower. Let us mark it with 3. And the reaction that takes place, the equation is there. Nitrogen dioxide dissolves in water in presence of oxygen to form nitric acid. The nitric acid is the main product. Now take one question again. Why is the absorption tower, why is this absorption tower made of quartz? I have written it on the board. QUARTZ. Why is the absorption tower made of quartz? Write the answer. As quartz acts as an acid resisting material. An acid resisting material. Finally, you can find that from that absorption tower, we obtain nitric acid. Now come to the first question that I had given it to you. Why there was a higher ratio of 10 volumes of air being required? The first reason you can get it from these 3 equations. All the 3 equations require oxygen. And that oxygen is being provided by that air. And secondly, air contains just 21% of oxygen. So in all the equations, oxygen is required, and that is why a higher ratio of air is required. This is all about the industrial manufacture. Remember, only 2 things we'll have to take for the exam: the 3 equations and the conditions. If you listen to my video, then you can prepare a good notes from that. You can take all the conditions. Condition, a high ratio of dry air, the platinum catalyst is being initially heated, the temperature is being lowered because the second equation takes place at a low temperature. Why is that absorption tower made of quartz? Because quartz acts as an acid resisting substance. Now, Rahul Murmu, tell me, did you understand this? And keep a notes of this also.
Yes, sir.
I know that today's class is being tiring because we had started the class a bit late due to the technical error with all the teachment apps. Whomsoever was conducting the class or was supposed to conduct that teachment app class at 11 o'clock, there was some network problem. Chandrakant. Hello, Chandrakant. Good afternoon.
Good afternoon, sir.
Good afternoon. Are you taking down the notes?
Yes, sir.
Okay. And then the last topic of the day. Just have patience. Take a screenshot or you write it down. I give you a couple of minutes time. 2 minutes time I give it to you. You take a screenshot, you write it down also. Then today's last topic.
Sir,
Yes.
sir, you given a question. Why is the catalyst initially heated? Sir, why it is heated?
Because the reaction being exothermic, sustains the reaction. So, few more information.
Sir, one more
Who had
question.
asked me the question?
Sir, one question, sir.
No. Who had asked me the previous one? I want to add few more answers to that. Come on, more clarification. Okay then. Now listen. Even if you stop hitting, that platinum catalyst, it continues to glow. In one of the test papers, this question is being given. Why does the platinum catalyst continues to glow even if the external supply of heat is being stopped? Same question that you had asked it to me. And the answer will be because the reaction is exothermic. Just try to recall. Once you lit that gas oven, एक बार जब चूल्हे को जलाते हो ना शुरू में, then that matchstick is being required, or that that it is being triggered only once. That lighter is being triggered only once. गैस लाइटर को एक ही बार ट्रिगर करते हैं और एक बार जब जल जाता है ना, then it sustains the burning. The burning continues. You don't need to trigger it again and again. Okay? I hope that the concept is now clear.
Yes, sir.
Somebody else was asking me with a question. Come on, put your name and then ask me the question.
Sir, Arpit. Sir, Arpit. Sir, there
Say
is
loudly.
one topic. Sir, there is one topic under the topic the laboratory preparation of nitric acid. The color of acid, the yellow color of acid is removed. That is not
Yes.
understandable by me.
Okay. Please write down the question, all of you. Very good question. Extremely good question. Why is HNO3 obtained in the lab? Why HNO3 obtained in the lab? Has a slight yellowish color. HNO3 obtained has a slight yellowish color. And the second one is, how could it be removed? This is why I say that don't miss the school teaching, particularly this particular subject. Now, look at this equation once again. Look at this equation. I told you that nitric acid is bit unstable to heat. And it is being prepared by heating only. Now, when nitric acid is being prepared either by lab method, the diagram is still there for you, or by industrial method, you see in each and every step heat is being required. Some amount of nitric acid gets decomposed to NO2, and the slight yellow color is because of this nitrogen dioxide. Did you understand?
Yes, sir.
So what is the reason for the slight yellow appearance of the acid? Nitrogen dioxide, NO2, that is formed due to the decomposition of the acid. And this could be removed by two ways. Either by diluting with water or by bubbling air through HNO3. So, in how many ways the yellowish color could be removed? The yellowish color could be removed in two ways. Either by diluting it with water or by bubbling air through it. You had asked me a very, a short question and had given you elaborate answer to that one. Even if your question is being asked in a number of ways, you are there to answer to it. Did you follow? Ananya, can you hear me today? Last day you didn't respond to me at all.
Yes, sir, I can hear you.
Yes. Last day, why didn't you respond to me better?
Actually, my
But
device
today's
is not
class,
working.
all right. You could have WhatsApp me, no? You could have WhatsApp me, sir. Because of this reason, I was unable to answer to your questions. So study properly better, okay?
Okay, sir.
Yes, you belong to my department only, Department of Chemistry. Please take a screenshot of this one, all of you. Then we move to the last topic of the day, as well as of the chapter.
Sir,
Yes.
sir, why the pure nitric acid is colorless? It will also decompose by thermal decomposition.
No, once it gets say, if it is pure, then there is no question of its decomposition. When it gets decomposed, then only the yellowish color appears. And that is also not the entire acid. A very small amount of that acid, if it gets decomposed, then that yellow color is due to NO2. Pure HNO3 will be colorless. Pure HNO3 means what? It didn't undergo decomposition. If it gets decomposed, then only these impurities will be added, and no more it will remain pure. Got the answer?
Yes, sir.
Yes. And the last topic. I simply appreciate all of you that in spite of being an initial interruption in the class, you are still there to attend the class now. You're still there to attend. And these patients will pay you off. Remember that. These patients that you are having it today will pay it to you. The last topic. Last topic is about the properties of HNO3. There are only two properties, only three properties that you will have to understand. One is the oxidation of copper metal, second oxidation of carbon, and the third one is oxidation of sulfur. So under these properties category, you'll have to study just one: oxidation of copper, carbon, and sulfur. I write down these equations for you. Copper plus nitric acid. Here the nitric acid is hot and concentrated or hot and dilute. Any one. It will react to form copper nitrate plus water plus nitrogen dioxide, reddish brown. Second equation, copper plus 8HNO3. This time the HNO3 is cold and dilute. Cold and dilute. Or moderately concentrated. Here it will form copper nitrate plus water plus NO. So with copper, there could be two reactions. One with hot and concentrated nitric acid or nitric acid in hot condition. And the second one, when nitric acid is reacted, it's normal temperature, cold and dilute HNO3. And the remaining two equations are carbon plus nitric acid will form carbon dioxide plus water plus nitrogen dioxide, and sulfur will form sulfuric acid plus water plus NO2. So here carbon is oxidized to carbon dioxide, sulfur is oxidized to sulfuric acid, and the color of these is reddish brown. So only 4 equations you will have to remember. Only 4 as far as the properties are concerned. That is all about today's class on HNO3, strictly based on syllabus. So today, if I revise, then in HNO3, we had discussed 3 topics. Topic A, B, and C. C is there in front of you. A was the lab preparation. B was the industrial manufacture. And C was the chemical properties. So under these 3 topics only, we expect all the questions to come in your final examination. Take a screenshot. Today you have shown a lot of patience. I don't want to test your patience further. Have a nice day. Bye-bye. Bye-bye, all of you.
Bye, sir.
Yeah, you may quit. You may leave the class now. Thank you.